For more information, please visit our website at DarkCybernetics.com. This is DarkCybernetics 101 C++ Programming. Follow along with our free course documentation. In the C++ programming language, the identifiers and other keywords are considered case sensitive, meaning that there's a difference between the way words are typed and performed in C++. The syntax is the general structuring of the way the arguments are developed, and there are keywords in C++, but these reserved words cannot be used in our programs when we decide to do programs and other activities. Also, the primitive data types in C++ include characters, booleans, floats, and others. So suppose we had integers, characters, booleans, floating points, doubles, and void, and characters. Let's quickly decide what's the difference between each type of data type. We just need to know the size of each particular data type and their general uses in our program. When we have an integer type, we generally use the term int. We define the int value, and integers are real numbers. Real numbers can relate to speed, they can relate to finances. We can have a negative bank account, and these have a small size, and their size is denoted by, we can use the output stream, then type the variable, the identifier size of, and inside of the size of clause here, these parameters, we just need to type in the type we use, int, and we just use a semicolon, which is a terminating statement, and when we press the run button on our compiler, we should get the size of the particular int in memory. So it ran. We shouldn't have any errors, we hope. And we pull the thing up, see no errors, no warnings. We're using the code blocks compiler, and we press the run button here at the top, and it says the size of this integer is 4. Referring to number of bytes we take it up. Alright, so let's try another one. So we want to use character data as a primitive data type, or data type. We could use an inline here, \n, or something else to skip a space or skip a line. In C++, the entire argument is read as one piece of instruction, and as you notice inside of this thing, there is no. You can use Control-C or some Control-V to copy paste lines of code, but to the compiler, we could transform the bytecode into when we compile the code, or we go from machine language to a high-level language we use to compile. The computer does not recognize the white space here, and then so you just it read as one entire piece of instruction. So we could just really just type our arguments continuously or contiguously. And we also have to be aware of how to use the compiler. So if we have we want to put the char here, char, right, and we use a semicolon, and for character data, and characters are individual text features. Boolean is a true or false state, right? So if we have a Boolean value, we need to know if it's true or false for some type of conditional argument. Each line in the code is referred to as a statement. So for each statement, we need to be able to have some kind of arbitrator to tell the difference between the types of sizes for the variables or the condition of the states. Alright, so here we have a Boolean. The Boolean will be true or false. Next we have is a floating point value. Floating point is good for certain types of data. Suppose we wanted to know the area of a circle, and we need to use pi, so we would need floating point variables, or if we had to divide two numbers, and the small numbers, not large numbers. Later we'll talk about how to implement using long ints and long double ints for larger variables. There is a defined size we can have for each in and particular variable. Okay, we want to know the size of the floats. We type in float here, and if we want to do cout, we want to know the size of the double floating points. So we're just going to write the message here in the string argument. Here in quotations, when we would type things in quotations, as you will notice that this compiler tells us the difference between if the words spelled incorrectly, and this is a change from over the years when compilers were first created. They were now they're free, but they weren't when they first came onto the the market. Well, okay, we want to know the size of the we're doing doubles. We just need to type the word double here, and make sure you spell the word correctly. See, when it's not spelled correctly here at the top, it will not have will not be highlighted blue as an identifier word or some type of keyword inside C++. As you see, when the argument here void referring to a function, or sometimes the function can return null, or meaning no value. You need to see the output, right? We need to put quotes around it. So if you make comments inside of C++ and you do not include the words, you don't include the values. Alright, see, we have a problem here. Maybe we'll be able to fix this. We need to put the E here, right? That's fixed, and then we'll go back to the other line. Some compilers will tell you at the bottom when you type in certain variables and certain arguments, if your line that proceeds below is incorrect. There's a problem on line 20 or line on the last argument, line 22. It will tell you which line has a problem on it, and where it creates several other lines of issues. So if you have a problem at the top of your program, since it reads as one entire piece of instruction, we need to go about debugging our errors by sometimes painstakingly commenting out each line. Alright, so let's run it this time. We've typed in all the variables, and let's see what's wrong this time. Alright. Okay. So can we find the error? So we have a line error here, and it says there's a line on this argument. So we didn't type the size of word here, and we need to put that in the parameters of the function. And when we move the error line, it tells us what line the error was on, and it tells us the particular region and what was missing. Hopefully, by pressing the run button and pressing the the compile button, then pressing which is the build button, and then we press the run button, this will fix the error. And it says we have no errors now, but it gives us a warning because we had error before, and we believe that this should fix the error. But here, when we run the program, it'll run it as one particular line. You see, you have integers, and it says the size of this, and some spaces. All right. Okay. So we've compiled the program, and there are other ways of making the spaces between the line. We could go, we use the output stream and \n or /n, but this may not go here. When we press the button, it says there's an error on this line, and if we change it, move to a /n, and we run it again, let's see, will this fix it? No, it may have not fixed it. So let's talk about including that on another video. But let's go look at the output. We have to once we do some kind of error, we have to recompile the code, or it will just give us the previous example. And if there's an error, if you compile the program, you change a bunch of code. If it's just the executable will be different than the version we use. So one problem people have is that they use version control to, let's look at this. Well, we have integers. Well, the size of this was 4, the size of the character was 1, the size of the Boolean was 1, the size of the floating point value was 4, the size of the double value was 1, the void was 1, wide is 1, and the size of it is 2. So this is a brief introduction into the using the primitive data types or data types in C++. And for more information, please visit our website at DarkCybernetics.com.